Hello everyone. Today we will be discussing sets in Python. So as you know, sets are defined as collections of objects, and Python has a number of features and functions where we can use those to play around with sets. Let's see how we create sets in Python. That's the first thing. So sets are defined by placing curly braces around them. This is very much similar to a dictionary, but in a dictionary each element is a key value pair, as you've already seen. But in a set, the elements are single elements. So we can have something like my set is equal to 1, 2 and 3. The curly braces are the ones which indicate to Python that this is a set. Now a special requirement here is that sets cannot contain the element repeated. So if you say 1, 2, 3 and 3 again, Python is just going to simply discard 1c because it's only taking it as a collection of objects. Also, each of these elements by themselves have to be immutable. So you cannot have a list of 2 or 3 elements as one of the elements of the set. Each element has to be unique and immutable by itself. So this is the simplest way to create a set, and sets can have mixed data types. As you can see, you can have an integer, a string. This is allowed because it's a tuple, and as you know, tuples are immutable, as are strings. Let's run this and see. So the code works without any error, and that means that Python has accepted the arguments we gave it to create our set. Now as I said that sets cannot have duplicates, so what happens if a set is given values which are duplicate in nature? So we say 1, 2, 3, 4, 3 again and 2 again. So now in this instance the set will only contain 1, 2, 3 and 4. The second time it comes across these numbers 3 and 2, the set is going to just simply discard them, and the final set will only contain unique values. Now we can make a set from any other object as well. So for example, if we can pass it a list or a string, and the set function will just simply take each of these elements, separate them out and make a set for us. So let's see how it works. The third one here, now this you'll have to take care because we are trying to pass it a list here as one of the elements. Since list is a mutable structure, it cannot be passed as an element, and it is in this line we expect an error. So we run it. The first line 1, 2, 3, 4 as expected, the repeats are not there. The second line 1, 2, 3 again as expected. This is a list. Python took just the unique elements, discarded the last 2 which was repeated. But for the last code line here, we come across an error called unhashable type list. So basically Python is refusing to accept a list because a list is mutable. Now how do we create an empty set? We can sometimes need an empty set, and if you just simply say a is equal to a pair of empty curly braces, then Python will accept it as an empty dictionary rather than as an empty set. So in order to create an empty set, we use the function set and we pass it with no parameters. So let's do this and see what happens. So the first code has resulted in the formation of a dictionary, as we can see. The second code has resulted in the formation of a proper set. So the types of the variables are clearly outlined here. Now once you have a set with you and you want to modify it, what can you do to it? Let's see those functions. You could initialize a set with the numbers as we have seen before, but then you can add something to it. So you use the function, you use the method of the set object that you have created. Our set object is going to be called mySet, and then on mySet we are going to invoke the method add2. So what this does is it gives it an element. It tells Python I want to add 2 to my set, and then when we print it, it's going to say 1, 2 and 3. Now you can, instead of add, you can also use update, and update will do the same thing. You can give it a list. Python will not accept a list because it's a mutable structure, we have already discussed that, but it will take the individual elements of the list. And you can even pass it 2 lists, or a list and a dictionary. So here, or a list and a set rather. So here we have passed it one list 4 and 5, it's going to unpack it, and another set 1, 6 and 8, which is also going to be unpacked before it is updated to the original set. And any duplicate values are obviously going to be discarded. So we'll run these cells and see what happens. So the first line, my set is 1, 3, that is alright, it's printed here. We added 2 in this line, so 2 appears here in the set. Now these are small sets, and they are appearing in order, but remember that a set is not an ordered structure. There is no indexing function in sets. It's just a bag of elements. So they can very well appear out of order as well. Let's try running this cell again. Yeah. So if you have a set with a larger number of elements, you are more likely to find that this is happening. We'll also see an example where it is made much more clear when we are using strings to initialize a set. So in the last one here, we have 4, 5, 1, 6 and 8 which have been added. The set already contained 1, so that has not been repeated. That is what has to be noted here. So this is how you add elements to a set. Now how do you take out elements from a set? Well, since there is no indexing, you cannot use it, you cannot remove elements like you would remove it from a list. So either you remove an arbitrary element. Let's see how that is done. So we, for an example, we initialize the set to 1, 2, 3, 4, 5 and 6. Sorry, 1, 3, 4, 5 and 6. There's no 2 here. We use the function called discard, the method discard, and we are specifying to the set that we want to get rid of the value which is 4. So once we invoke discard on this set, this 4 will disappear and we are going to be left with 1, 3, 5 and 6. Let's run this. So the first line prints out our set 1, 3, 4, 5 and 6. The second one discards 4, so you can see in the second line of output there is no 4 in the set. Now you could also use remove instead of discard, and it is going to do the same thing. In this set now, which is now 1, 3, 5 and 6 after discarding 4, we want to discard 6, so we are left with 1, 3 and 5 as it appears here in the third line, 1, 3 and 5. There it is. So remove can remove a specified element from a set. Discard can also do the same thing. So what's the difference here? Now if we try to discard something which does not exist in the set, the discard function is going to work just fine, in the sense that it's not going to throw up an error. It will try and look for the element we have passed. If it doesn't find it, fine, not a problem. But if you use remove is a more forceful function. It will try to remove 2 even if it doesn't exist, and because it cannot do that, there is no element 2 in the set, so it's going to throw us an error. So this is how it appears. It found a keyword error 2 because it tried to find key, could not find it, and it works differently from discard in this manner. Discard is more error safe in that way. Now this is about removing specific elements from a set. What about removing just an arbitrary element? So we can use the pop function there, and in this particular example we are going to initiate our set using a string. So we say my set is equal to set initialize using hello world. So each of the characters in the string hello world is going to be an element for our set. There is a repeat in L, there are 3 L's here, and there are 2 O's, so we are not going to see those repeated. So once we print my set, you'll see that the letters have appeared here. And now the point I was trying to make about these not being in order. So even though we have passed a string which reads hello world, the individual letters of the string are going to appear out of order because the set does not have any intrinsic order to it. Okay, now let's come to the pop method. We are using .pop on the set we've created, my set here. So it's going to take one single element from these and arbitrarily and just pop it out, and it's going to return that element to us. So the outcome of this set.pop method is going to be whatever it has popped. In this particular run it has popped O, but it could have been anything else also. You could pop another element, that's fine, and you could use the clear method to clear everything out of the set. So if you use the clear method, then all elements of the set are expunged and your set is now an empty set. So if you print my set, instead of printing the elements that were formerly there, it's just going to print out a blank set output, something like this. So you have to use pop carefully, because pop can give you anything from the set. You have no control over that. Now there are a specific set of operations on sets. You might have heard of these, like unions or intersections or subtractions. These can be used on Python sets as well, and we'll see how they work. So let's start with the set union. We have these two sets which we are defining for the sake of our demonstration. The first is 1, 2, 3, 4 and 5. The second set has 4, 5, 6, 7 and 8. Let's run the sets. Let's run the code to get the sets initialized. Now these two sets exist in memory after we have run the code. Union is a method which takes all the elements of the two sets that we are trying to unite, and it throws them all into a single bag. So if you thought of sets as a bag of elements, then now we have one single bag of elements containing elements from both the sets. It is also a set, and therefore there's not going to be any repetition. So if you are uniting A and B, and you can use the unite operator like this, A unite B, then the outcome is going to be every element that is contained in either A or B, but without repetition. So we are going to have, let's see, 1, 2, 3, 4, 5, 6, 7 and 8. So the 4 and 5 have been included just once. Now instead of the operator, you can also use the union method. So our set is an object, because as you know, everything in Python is an object. So set A, we invoke the union method and we give it the argument B. So what this line is telling Python is, take the set A and unite it with B. And the mirror image of this is going to be this code, which tells Python to take the set B and unite it with A. Since these two are going to achieve the same effect, they are also called symmetrical functions in sets. So the outcome is the same, 1, 2, 3, 4, 5, 6, 7 and 8 as in the above case. Now intersections are different from unions. Intersections take whatever is common to the two sets. So whatever elements occur in both the sets will go into the intersection set. And you can use the AND operator to create an intersection. So if we print out A and B, we are going to get only those elements which are there in both A and B. And these elements will be, as you know, 4 and 5. These are the common elements. So let's print it out. We get a set containing 4 and 5. Now we come to set difference. Now set difference is slightly tricky in the sense that unlike A union B being equal to B union A, and we have seen for intersection also, because it's common elements, so A intersection B and B intersection A are going to produce the same result. But set difference is going to keep in mind the directionality of it also. So let's see what's happening here. We've got the set A is equal to 1, 2, 3, 4 and 5. We've got the set B equals 4, 5, 6, 7 and 8. So these sets are different, but they have a few common elements which are 4 and 5. Now if we produce A minus B, what's going to happen? What do you think is going to happen here? So the way Python reads it is, it says I want to take set A but subtract B from it, which means everything in set A is to be included except those things which are present in B also. So set A is 1, 2, 3, 4 and 5. This is where Python will start to work. It wants to include element of this set, but it doesn't want to include anything which has been included in B. So of these, 4 and 5 are already in B. So Python will say I don't want these two because they are part of B. So 1, 2, 3 are acceptable to me. Now what happens to 6, 7 and 8? They are present in B, but they are not present in A. So for the purpose of A minus B, all elements in B which are not part of A are just going to be ignored. So we are going to end up with just 1, 2 and 3. Let's run it. So you see we have 1, 2 and 3. Now because of the base set being A here, in A minus B we start with A. In B minus A we would start with B. Therefore the outcome of the two A minus B and B minus A is not going to be the same. So that's an important point to remember. If you are taking a set difference, be sure, do you want A minus B or do you want B minus A? Okay. Now let's take a look at something called the set symmetric difference. So now this is in a way very similar to intersection, or rather I should say the reverse of intersection. What a set symmetric difference does is, it takes your two elements, two sets A and B, and it's going to say, okay, I have A, I have B, so I want everything that is there, but I don't want anything that is part of both the sets. So in this case, it's called set symmetric difference because it doesn't matter what base you are taking, because we're going to consider both the sets together. So we got 1, 2, 3, 4 and 5, and then 4, 5, 6, 7 and 8. So all elements except the intersection elements. So 4 and 5 are happening in both the sets. They exist in both the sets. So the outcome is going to not include 4 and 5, but everything else. So let's run this and see how it appears. Yeah. So we have 1, 2, 3 from set A, 6, 7, 8 from set B, but we have not included 4 and 5 because they were the intersection. They were there in both the sets. So intersection produces only the elements which are common, and a set symmetric difference produces everything but the intersection. So these are the various functions and methods we use in sets. I hope you enjoyed this session, and I'll see you in the next one.